Hello everyone, I'm Tejas Hirawat, a CSE undergrad at Bennett University, and today we are going to be studying about greedy algorithms and optimization problems. To understand greedy algorithms, we must first understand the problem to which they provide a solution to. These problems are known as optimization problems. In an optimization problem, the main objective is to either maximize or minimize certain values. Let us further understand some basic terminology related to optimization problems using an example. Suppose you have a problem P, where you have to travel from point A to point B in, let's say, 12 hours. Now we know that A and B are far apart. Now you have the following options which you can use. You can either walk, you can take a car or a bike, you can travel via a train, or you can travel via an aeroplane. Now, since we know that A and B are far apart and 12 hours is a short time, we can say that walking, taking a car or a bike are not suitable. Hence, these become the non-feasible solutions. The rest, that is taking a train or an aeroplane, they become the feasible solutions of the problem. Now, let us add a constraint to the problem. Let us say that the cost has to be minimum. This makes it a minimization problem, and generally speaking, trains are cheaper than aeroplanes. Hence, the train becomes an optimal solution to our problem. Now that we have understood this basic terminology related to optimization problems, we can move on to the definition of greedy algorithms. Greedy algorithms are an algorithmic paradigm that follow the problem-solving approach of making the locally optimum choice at each stage, but do not guarantee a globally optimum solution. To put it in more simpler words, this means that a greedy algorithm picks the best immediate choice and never reconsiders its choices. To further understand what a greedy algorithm is, let us look at some pseudocode. One thing to keep in mind is that greedy algorithms often divide the problem into certain subparts. These subparts are then put into the algorithm as an input. This input is then checked. If the input is feasible, then it is added to the solution. Otherwise, it is discarded and the other alternatives are approached. Let us move on to the pros and cons of a greedy algorithm. Greedy algorithms are simple and easy to implement. They are more often efficient algorithms which have time complexities of n log n when used with the right data structures, which is much better when compared to the n square efficiency which we find in a lot of brute force algorithms. But there is a catch over here that greedy algorithms do not always provide us with a globally optimum solution. Hence, they can only be applied to certain problems. Let us look at an example where greedy algorithms fail to provide us with an optimum solution. Let us suppose that there is a tree as shown in the screen. Now we have to find the maximum possible sum by following only one path, and we need to find that path out. Now if we use the greedy approach, we'll first go from 4, then we'll go to 5 since 3 is less than 5, and then we'll go to 6 since 6 is greater than 2. Hence the total sum we find with the greedy method is 4 plus 5 plus 6, which sums up to 15. But as you can see, there is another optimum solution over here. If we follow the non-greedy method and if we go from 4 to 3 and then we add 10, we get a total of 17, which is using this path. Now, this is where a greedy algorithm fails to provide us with an optimum solution. Now that we have seen that greedy algorithms can fail to provide us with an optimal solution, we also need to understand the criteria which we need in a problem to apply a greedy method. The first is the greedy choice property. This means that the global optimal solution of a problem is also its local optimal solution. This essentially is a best case scenario for any greedy algorithm. Next, we have that the problem should have an optimal substructure. What this means is that the optimal solution of the problem can be found out using the optimal solutions of their subproblems. Moving on, let us discuss certain applications of a greedy method. We have Prim's and Kruskal's algorithms, which basically are used to find minimum spanning trees. Then we have Huffman coding. This is a compression algorithm which is used in famous softwares like WinZip, and in image formats such as PNG and JPEG. Then we have knapsack problem and job sequencing problem. Both these problems are to maximize productivity or profits. In the knapsack problem, we are given certain objects with a profit and a weight. We are also given a container with a fixed capacity. And usually, the capacity of the container is less than the summation of the weights of the objects. In job sequencing, as the name suggests, we have to schedule jobs according to their deadlines. With this, we have come to the end of this video. I hope that you understood all the concepts, and please feel free to drop any questions in the comment section. Thank you and have a great day ahead.